Let's take a look at what happens when we react ethers with an acid. And in this case we have a cyclic ether, but that's not going to change too much. And we're going to assume we have an excess of hydrobromic acid for this reaction. So remember that the oxygen on our ether has lone pair electrons. So this can act as a nucleophile and attack the H plus of the acid. So attack the proton and we'll lose the bromine. So we'll draw the product of this. So we get that protonated ether plus Br minus. So now we essentially have a good leaving group, a positively charged oxygen, and we have Br minus, which can act as a nucleophile. So what I'm going to do now is use this bromine as a nucleophile, attack this electrophilic carbon, and then just kick off this alcohol. So this step actually breaks our ring. So now I have a bromine attached there. And over here, I just have my OH group that came off. Well, now if I have an excess of HBr, so now I'm going to use this lone pair on the alcohol as my nucleophile, attack my proton, and displace the bromine. By doing that, I get OH2 plus, which is again a good leaving group. I also generate Br minus in that step. Well, now I have an electrophilic carbon, a nucleophilic bromine, so I can attack that carbon and lose water. So in the case of this reaction, from this cyclic ether, I formed this dibromide, and then of course the byproduct of this is just water.